Okay, so the math dealer here, and today we are going to learn how to solve a system of three equations without using matrices. I know we're going old school, but you know what? Us Algebra 2 teachers, sometimes we like it that way. Okay, so the first thing we're going to do here, all right, is I'm going to follow these steps. The first step says, group two of the equations together and cancel one of the variables. It doesn't matter which two you pick any two. Maybe these are your favorite two. Go for it. So I'm going to take 2x plus y plus 3z equals 9. And then I'm going to take an x minus 2y, oh, I need to be neater, plus z equals 8. Now, I'm going to cancel one of these variables, right? It doesn't matter which one you cancel. So I think I'm going to actually cancel out the x's. And in doing so, I would multiply the second equation by a -2. So I'm really hoping that you learned how to do systems of equations back in the day, all right? Because that's really what I'm doing. 2x plus y plus 3z equals 9. And now remember, you got to distribute. You've seen pictures. This is going to get me -2x. I really need to be neater, don't I? Plus 4y minus 2z equals a -16. Now, fun fact here, like, check it out. They cancel. Always fun. And I'm left with 5y plus z equals -7, okay? Now, I'm going to hold on to this equation, okay? I'm going to hold on to that, and I'm going to tuck it over here. 5y, right? And then I'm going to say plus, I think that says z. What was that z? Yep, just a z, good old-fashioned z, equals -7. You know it's bad if I can't even read my own handwriting. Okay, now, second step. Group two different equations together, but you have to cancel the same variable. All right, so I'm going to group two different equations together. Well, I think it might be easiest to group the first and the third together. And like I said, it is totally up to you, whichever ones you want to group together. So I'm going to slide down here, and I'm going to say, okay, well, I have 2x plus y plus 3z equals 9. And then, of course, I have -4x plus 3y plus 2z equals -4, right? All I've done is just rewrote these first equation and the third equation. But now I'm going to solve them systematically like I did earlier. In this case, I'm going to have to cancel out the x's. So in order to cancel the x's, I'm going to multiply it by 2. And that's going to give me a 4x plus 2y plus 6z equals 18. And the second one down here, that stays the same. I didn't multiply him by anything, so he just gets to chill. That's actually a 4. I know. What the heck is going on with my pen? That's all right. You get the picture. So 2z equals -4. Now, combine these guys together. Check it out. I'm left with 5y, right, plus 8z equals, and this is 18. That is a 4. I know it doesn't look like a 4, but I swear it's a 4. 18 minus 4, which gives me, oh, by the way, 14. Okay, so now that equation, I'm going to use this as my second equation, right? So that's 5y plus 8z equals 14. Okay, now step 3, all right, step 3 is the big one, okay? Step 3 says take the two equations from step 1 and 2 and then solve them systematically. So I'm literally going to solve these equations together, all right? So this green and the blue one together. I hope you're not colorblind. All right, so here we go. So in order to do that, I'm going to multiply the second one by a negative, which is always fun because the y's cancel for a little while, not forever. So that gives me -7z equals, and I'm pretty sure that was a -7 and a -14. I know, I'm struggling with my writing here. So that gives me -21. So that leaves me with z equal to 3. But I am not done yet, no siree, right? Because since I found z to be 3, I could plug it back into either equation. I think I might just go back into this green one. All right, and I'm just going to plug in my 3. So that gives me 5y, right, plus 3 equals -7. And then I'm going to solve this. So that gives me 5y. Yes, I will move the screen up, I promise. It's getting tight down there, right? So that gives me y to be actually -2. Okay, so check it out, right? You're like, all right, I see you, math dealer. I see what's going on here. So now I found a z and I found a y, right? Because my y, remember, was -2. Okay, see if my pen has a delay going on. What the heck? I'm dying here. Okay, so I have z is equal to 3. I have y is equal to -2. Now, the last one, right? Step 4 says go back to one of the original equations, okay? Now, one of the original equations was a 2x plus y plus 3z equals 9, okay? Now, I'm definitely going to take my z, which is 3. I'm going to plug him in, okay? Yes, I'm going to take my y, which was negative 2, and I'm going to plug him in. And now I'm just going to go and solve. Oh, that's a 2, I swear. And I'm going to go solve for x. So, fun fact, I get 2x minus 2. And of course, remember, I plugged the 3 in for my z, right? 3 times 3 is 9. I hope I don't want to get that wrong. That would be awkward. So that going to give me 2x plus 7 equals 9. Yay, team. So that gives me 2x is equal to 2. Oh my God, I'm going to run out of room again. And that gives me x equal to 1. All right. So you have just found all 3 variables. Literally, you found an x, you found a y, and we weren't even in the alphabet. Yes, you found a z also. Yay, team. So that means you're ordered triple, the way you would present your answer. The one you're going to star, call it your own, right, is going to be x, which was 1, y, which was negative 2, and z, of course, which is 3. All right, that is how you get the solution to solving a system of 3 equations. I really hope this was helpful. And yes, there is an easier way. There's a faster way. It's called matrices. But hey, we're in Algebra 2. We haven't learned those yet. We will soon enough. All right, this is the Math Dealer signing out. See ya.